So we're looking at AS vectors, 8.3 magnitude and direction of a vector. So like we've just talked about, magnitude means size. And so when I'm considering this vector, xi plus yj, that means we're going across for x and we're going up for y. And because these, which are Cartesian coordinates, it's working the same as coordinates, are always going to be at right angles. If I am looking for the size of the vector that goes from the starting point to the finish point, then I'm just using Pythagoras. That is supposed to be a straight line, but let's not worry about that. So we've got this vector here. The notation for magnitude is just vertical lines around the vector, so it looks like that. We look at that notation as a function when we're doing A2 pure, but for now we just need to read it as meaning size. So by Pythagoras, this squared is equal to x squared plus y squared, so the square root of x squared plus y squared is equal to the magnitude of that vector. So I suggest that you pause the video now and have a go at these three questions here, and then I'll go through them. So number one, if we're looking at the magnitude of 2i plus 3j, I'm just doing square root of 2 squared plus 3 squared, which is equal to root 13. If the question asks for exact, you would leave it in third form. Otherwise, you are all right to go to three significant figures. Question 2, the magnitude of I minus 7j is equal to the square root of 1 squared plus minus 7 squared. If you're doing that on your calculator, you need to watch for that minus sign. So make sure you put those brackets around it. But to be honest, if I'm doing this on my calculator, I recognise that when I'm squaring, that minus sign goes, so I wouldn't even bother typing that in. And by thirds, we can split 50 up as 25 times 2, which gives me 5 root 2. Let's give it as an exact, and let's put it as a simplified third, just because we can. So we've got this vector here, square root of 1 squared plus 1 squared, which is equal to root 2. And that's it, that's how you find the magnitude. So if we look at the next section then, so unit vector, we have already defined unit vector means that it's got magnitude 1. So we want it to go in the same direction, but we need it to have a length of 1. So if we look at this expression here via an example, so if we consider the vector v, we know that we're going 3 across and 4 up. Therefore, by Pythagoras' theorem, that is 5. If you need your working out for that, you are just doing 3 squared plus 4 squared, which is equal to 25, and I'm square rooting that, which is giving me 5, but it is the 3, 4, 5 triangle, so it's a Pythagorean triple. If you recognise something like that, you are all right just to write it down. So what we're saying is we're going 3 across and 4 up. We know that a scalar multiple of the vector 3, 4 would be parallel to this vector here. So any multiple of that, so 6, 8 would go across, up, it would be parallel to that. It would go in exactly the same direction. So because this has got length 5, what I want to do is say, well, I'm splitting that up so that I want this vector here. So I want to know how many across I need to go and how many up I need to go so that that has got length 1. So if that's what this is doing. So we're taking the vector that we have, so that 3, 4 is giving us the direction, and then if I divide that by that length, then we have our unit vector. So that's what we've got there. Find the vector of magnitude 3 in this direction. So we're going in the direction 1 across, 1 up. So we know that the magnitude of that is root 2. So what I want to do is get a unit vector. So to get the unit vector on this, we are looking at 1 over root 2. of I plus j. So that's the unit vector. So we know that that has got length or magnitude 1. If I want it to have length 3, all I need to do is multiply it by 3. So that is going in the direction of I plus j. That makes the magnitude of this 1, and then timesing it by 3 will give you a magnitude of 3. So we'd be going along this line, but the length of it would be 3. So that's magnitude. Direction. So the direction of the vector is the angle between the vector and one of the coordinate axes. We generally work with the positive x-axis, but you need to make sure you're reading the question because it might specify that you put it in a certain place. So we define a vector by giving its magnitude and direction rather than the ij notation. So we need to be able to switch between the two. When we're looking at modelling, we might be using this in trigonometry, or we might be using this in bearings. If you've got this triangle then, so just like we did with Pythagoras' theorem, if that's x and that is y, then, and this is the vector A going up here, then this is the angle that I'm concerned with. So we're looking for this angle here, which is just inverse tan, because by TOA we've got opposite over adjacent. So tan theta is equal to y over x, which is where this has come from. Okay. So calculate the angle between this vector and the positive x-axis. A diagram is always helpful. Okay, so that just make sure you are considering where your positive x-axis is. So I'm looking for this angle here. So we've got tan theta is equal to 5 over 11. You don't need to learn the formulas for this. Just by drawing the diagram, it turns it into a GCSE question. You should be able to just work it out from there. So we've then got theta is equal to 24.423 significant figures. Just as an aside, so if we had v was equal to, let's do minus 11 plus 5. So I've got minus 11i plus 5j. If we were thinking about that, so that's the origin, that's 0, 0 in terms of a coordinate, and that's your x-axis. So minus 11 plus 5 is over here. The angle that you are after is this one here. This is why the diagram is useful. Now, in order to find this angle, so let's call that one alpha, I can kind of almost drop that minus sign. So I'm just thinking it's 11 across and 5 up at this point. I'm just thinking in terms of sizes. So we get that alpha is equal to 24.4 by doing tan alpha equals 5 over 11. That's just this bit here. Therefore, theta is equal to 180 minus 24.4. So we get 156 degrees. Okay, so that's if you've got your minus sign in there, which is why we say draw a diagram, because it will help you map it out. So you've got 3 questions here, so pause the video, have a go at these, working out the magnitude and the direction, the angle with the positive x-axis. When you have a question where you're going below the axis, it's up to you whether you take it to be a negative or whether you take it to be a positive and do it as a reflex angle, because your diagram for this is 1 across and 3 down. So that's the vector that you're dealing with there. So your x-axis is here. So you can either work this out and take it to be a negative angle, or you can come all the way around and take it off 360. That is up to you. So I'll let you have a look at those questions. So we've already talked about that one. So we've got 3 across and 4 down. So it's a 3, 4, 5 triangle. We're doing tan to the minus 1 of, it's this angle I want here, opposite over adjacent, which gives me 53.1 degrees. So we'd either say we've got minus 53.1, or we could say it's 53.1 below the x-axis. The exam question might tell you which way they want it. Or you could say it's minus 53.1 degrees, or you could say it's 306.9 degrees. Okay. Make sure you're happy with all of those. So this one, 1 squared plus 3 squared is 10 squared. So the magnitude is root 10. I'm doing tan to the minus 1 of 3 over 1, which is equal to 71.6 degrees. So again, you've got the same 3 situations. We can say we've got 288.4 degrees with the positive x-axis. Or minus 71.6 degrees below positive x-axis. Sorry, that should just be a positive if I'm saying below, and then the minus sign would be the alternative one, so minus 71.6. Last one then. So we're going minus 6 and minus 3. So I've got 6 there, 3 there, that's the origin. So your x-axis is over here. Magnitude square root of 6 squared plus 3 squared is root 45. Nine goes into that, doesn't it? So square root of 9 is 3 root 5, if we're simplifying that down. 10 to the minus 1 of 3 over 6, which is equal to 26.6 degrees. So I am looking for, with the positive x-axis, I'm looking for that angle there. So we've got 180 degrees, add 26.6, which is equal to 206.6 degrees with the positive x-axis. Like I say, your exam question will make it clear whether you're okay to go below, but as long as you state it and you're clear with your answer, you should be absolutely fine with that.